In addition to using the Unit 2 tool alone, we want to see the connection between our Unit 1 descriptive statistical techniques, which involve examining distributions and relationships, and the subsequent tests that we run with that information that we calculate. For example, what if we wanted to test whether men spend on average $4,000 on the credit card in a month? So we're testing the assumed population mean of 4,000, but we're doing that just for the men. So the first thing we need to do is use our grouping tool on Unit 1 to obtain the sample information on spending just for the men. Here we're going to assume a population standard deviation of $1,000. That we're given, but we need to obtain N, the number of men in our sample, and we need to obtain X bar, the sample mean or average spending for men in our sample data. Once we get that information, we could use our Unit 2 tool to run the z-test for the population mean. So this problem has to be done in 2 steps. The first step is obtaining our sample information. We'd like to know about the amount charged, and we would like to group those amounts by gender. So we first have to input the variable number 3 for our quantitative amount charged, and the variable number 4 is our grouping variable gender. On the Worksheet tab Grouping, we could filter the amounts only for men. And that's what we've done here. So our sample mean is $3,695.18. We're assuming a population standard deviation sigma equal to 1,000, and our sample size N is equal to 49 men. Now that we have the information that we need from the sample data, we could go to our Unit 2 tool and run the z-test for the population mean. We first need to input our sample size N, which is 49. Our sample mean we could obtain from the Unit 1 tool simply by typing equals, changing over to our Unit 1 sheet, and clicking on the cell where our sample mean is. Once we hit enter, the sample mean will appear in the right place. We could also just make a note of the sample mean and type that in manually. Either way is fine. The assumed value for sigma, $1,000. Finally, we need to run our test. We're assuming as a null hypothesis that mu equals $4,000. And here are our results. The sample mean, amount charged by men, is actually 2.134 standard deviations of X bar below 4,000. This is clearly beyond 1.96, which is the standard at 5% alpha for statistical significance. So here we could see we are rejecting the null hypothesis that mu equals 4,000. Our sample mean is significantly less than 4,000. So we would conclude that men in the market do not spend on average 4,000. And further, we could see that they spend significantly less. The p-value, of course, will get us to the same conclusion. When the p-value is less than alpha, we reject the null. Here our p-value of 0.0329 leads us to the same conclusion, rejecting the null. Finally, our confidence interval will allow us to estimate what the average spending by men is in the population. And at 95%, I can see that the range is 3415 to 3975. In other words, I am 95% confident that the population mean amount charged by men is somewhere in the confidence interval. Further, I could see that 4,000 is not in the confidence interval at all, supporting our decision to reject the null. What if we were interested in the proportion of women who spend at least $4,000 in a month? For example, the credit card company assumes that the percentage of women who spend at least $4,000 in a month is 50%. We'd like to test to see if the percentage of women who spend at least $4,000 is no longer 50%, or in other words, if that assumption needs revision. This is going to require that we use both Unit 1 and Unit 2. Specifically, we're relating gender and spending. The best way to work this problem would be to use cross-tabulation to obtain the percentage or p-hat value of women who spend in either Category 4 or Category 5. Spending in Category 4 is between $4,000 and $5,000. Category 5 is over 5,000. So the percentage who spend at least 4,000 would be the percentage of women who spend in either Category 4 or Category 5. Our crosstab will help us obtain not only the sample size for women, but the number of women who spend in either of those two categories. Finally, then we could use that sample information to run our z-test for proportion, assuming a test value for p equal to 0.5 or 50%. So this problem also has to be done in two steps. First, we need to do our descriptive analysis, running our crosstab relating women specifically, or gender in general, to the amount charged. But because we're cross-tabulating, we're forced to use a categorical version, variable 7, of amount charged. Recall that spending Category 1 is in the 1,000s, 2 in the 2,000s, and so forth. So we're mainly interested in Categories 4 and 5 because those are the women who spend at least $4,000. Looking at our crosstab results, we could see that 71.67% of the women in our sample spent in either Categories 4 or 5. In other words, a p-hat sample proportion of 0.7167 represents the proportion of women in our sample who spent at least $4,000. There are 60 women in our sample. That sample proportion comes from adding the number of women who spend in Category 4 or 5, at least $4,000. So 21 plus 22 is 43. 43 of the 60 women spent at least $4,000. Now we can use that sample information and our assumed value for p equal to 0.5 or 50% to run a z-test for proportion. So our sample size n is 60 women. And we just obtained from our cross-tabulation the number of women who spend at least $4,000. In other words, the number of women who spent in either category 4 or category 5. That was 43. So our p-hat, there it is, our 0.7167. We're assuming that 50%, the credit card company currently assumes that 50% or 0.5 of the women are going to spend in that range. Quite clearly, we have more than 50%. Our p-hat value is closer to 72%, which is 3.36 standard errors above 0.5. So our two-tailed p-value is well less than 5% alpha. This result is not only significant at the 5% level of significance, this is a highly significant result. Our result is statistically significant at the alpha equals 1% level, which is why we can say the result is highly statistically significant. In other words, instead of just rejecting the null of 50%, we strongly reject the null of 50%. Our 95% confidence interval gives us a more practical way to understand why. We are 95% confident that the true percentage of women who spend in category 4 or category 5 is somewhere between 60% and 83%. That interval range not only excludes 50% or 0.5, but it is well above 0.5. This concludes the video, Introduction to Statistical Inference, Z procedures for proportions and means.